Our topic for today is all about postulate and triangle congruence. We have SSS, ASA, SAS, and AAS. Let's talk about this one by one. We have SSS, or side-side-side postulate. If the sides of one triangle are congruent to the sides of a second triangle, then the triangles are congruent. Let's have an example for this. If side AB is congruent to side DE, and side AC is congruent to side DF, and side BC is congruent to side EF, then triangle ABC is congruent to triangle DEF by SSS postulate. We have SAS, or side-angle-side postulate. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Let's have an example for this. Included angle. What is included angle? The angle between two sides. If side MP is congruent to side RS, side NP is congruent to side QS, and angle P is congruent to angle S, then we can say that triangle MPN is congruent to triangle RSQ. Since angle P and angle S are included angle, then we can conclude that the two triangles are congruent by side-angle-side postulate. Now, let's proceed with the third postulate. We have ASA, or angle-side-angle postulate. If two angles and the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. Now let's have an example for this. Included side. So what is included side? The side between two angles. Let's have angle B is congruent to angle Y. Side AB is congruent to side XY. And angle A congruent to angle X. Then, we can conclude that triangle BAC is congruent to triangle YXZ. If you're going to observe the two triangles, we can see a side in between two angles. That's why the two triangles are congruent by angle-side-angle postulate, or ASA. Let's proceed with the fourth postulate, or theorem. Next, we have angle-angle-side theorem. If two angles and a non-included side of one triangle are congruent to the two corresponding angles and a side of a second triangle, then the two triangles are congruent. Let's have an example for this. If angle C is congruent to angle F, angle B is congruent to angle E, and side AB is congruent to side DE, then triangle ABC is congruent to triangle DEF. We're going to observe the two triangles, side AB and side DE are congruent, but then they are non-included side. Those sides are not in between the two angles. Therefore, the two triangles are congruent by AAS theorem, or angle side theorem. Now, aside from those four postulates or theorems, there are still postulates and theorems that are not considered as proofs on triangle congruence. There is no such thing as angle-angle postulate. I mean, AAA postulate. Why? Because it is possible for two triangles to have its angles congruent, but their sides have different measures. Look at my example here. If you're going to consider the two triangles, you will be able to see that the two triangles have exactly the same measure of interior angles, which is 60 degrees. But if you're going to look at the measures of its sides, they are different. Then we can say that the two triangles are not congruent. That is why there's no AAA postulate. And aside from that, there is no side-side angle postulate also, because it is possible to construct non-congruent triangles given that two sides and non-included angle are congruent. Take a look with my example. Consider the two given triangle. As you can see, both triangles have 45-degree interior angle. We have side AB congruent to side ED, side AC congruent to side EF. But, generally speaking, if you're going to look at the two triangles, they are completely different. Therefore, they are not congruent. That is why there is no such thing as ASS postulate. So, we can write our idea in general. Angle ABC is not congruent to triangle EDF. This time, let's have practice or exercise to find out if you were able to understand the topic about postulate on triangle congruence. Of course, you need to follow the instruction. Identify if the two triangles are congruent or not. If congruent, which postulate is applicable to each? And I would like you to write the congruence statement. Okay, let's have this. Number 1. Side MI is congruent to side KE, and side IK is congruent to side EM. Based on the illustration, we can say that side MK is congruent to side KM. It's the application of reflexive property of congruence. Therefore, the two triangles are congruent. So, our congruence statement will be triangle MIK is congruent to triangle KEM by SSS postulate. Okay, second exercise. Angle P is congruent to angle Q. And angle PRS is congruent to angle QRS. And we have side RS is congruent to side RS. using reflexive property of congruence. Therefore, the two triangles are congruent. So the congruent statement would be triangle PRS is congruent to triangle QRS. By what postulate? Well, we have AAS theorem. Third example, angle BAC is congruent with angle DAC, and angle BCA is congruent with angle DCA. And based on the illustration, we can see that side AC is congruent with side AC using reflexive property of congruence. Thus, the two triangles are congruent. So our congruent statement would be triangle ABC is congruent to triangle ADC by ASA postulate. Fourth exercise. Side AC is congruent to side EC, and side DC is congruent to side BC. And using the vertical angle theorem, since line segment AE and line segment BD intersect at exactly one point, therefore, we can have two sets of vertical angles, and we all know vertical angles are congruent. Therefore, angle ACB is congruent to angle ECD using vertical angle theorem. Thus, the two triangles are congruent. Angle ACB is congruent to triangle ECD by SAS postulate. Last exercise. Side NP is congruent to side LP, and side NO is congruent to side LM. And using vertical angle theorem again, we can say that angle OPN is congruent to angle MPL. So do you think the two triangles are congruent? No, it is not congruent. Why? Because there is no such thing as side angle or ASS. Thus, your statement would be triangle OPN is not congruent with triangle MPL. Okay, thank you for watching. That's all for today. This is Miss Mel.